So today's class is about Docker. So the major difference, okay, so till now we have worked with so many tools. Okay, in AWS also we practiced done we have done so many topics in AWS also, like auto scaling, load balancer. So everything we have done. So the major importance of Docker. So at the starting of classes, I have already explained the different types. Okay, so and one of them, so at last, that means the deployment tools. Okay, so we can do the deployment tools in many ways. So one is by writing the scripts, okay, by using shell scripts. Okay, and next one by using deployment tools like Jenkins. Okay, so Jenkins, Ansible, Tomcat. So by using these tools, we are doing the deployments. And next to process is containerization tools. Containerization tools. So mostly recently, okay, most of the companies are preferring these containerization tools like Docker and Kubernetes. So these two are very famous, and most of the companies are adopting these two. Okay, so what is the importance of containerization tools? What is meant by containerization tools? Means, so these tools are using the containers. Okay, these tools are used the containers for deployment, for deploying the application, for deploying the applications. So that is that's why these are called as containerization tools. Okay, or we can also call as orchestration tools. Orchestration tools. Okay, so what is meant by Docker and what is meant by Kubernetes? So first we will come with the Docker. So Docker is nothing but it is a containerization tool. Okay, so the major advantage, major application, why we are using the Docker. Okay, so previously in one of the topic, okay, we covered. So I just give one scenario. You can tell me what is the topic that. So I want to run two applications. Okay, I want to run two applications in some number of machines. Okay, why? Because if one machine is goes down, so the remaining will serve the application to the customers. So for this is a scenario for this, what we can do, how we can achieve this scenario. Anybody? So I have two applications in some number of machines. Okay, I want to keep two applications in some number of machines. For the safety and high availability, we can call that term as high availability. So high availability purpose. So I want to keep the two applications in a number of servers. So for this, how can I achieve this? So what are the different processes? What are the different procedures we can do? Anybody?
Can we use AMI there?
Of course. So one is the method AMI. The first method is AMI, Amazon Machine Image we can use. Next one. We have covered the topic. Auto scaling.
Yeah.
Okay, so these are the two methods. Okay, we can use. Okay, but what is the problem of these two methods? So one is, for example, if you go with AMI, okay, so the package is available. Okay, the package is available with the two applications, but you need to, what's the drawback? But you need to create the instance, right? Okay, you need to create the instances manually, but that is not a good one, because every time if the application is go down, okay, so again you need to create one machine and you need to copy that applications into the you need to create the instances by using the existing AMI, but that is not a good practice. So that's why we are not preferring the AMI. So we have also some issues with auto scaling. So no doubt auto scaling is a good technique. Okay, So which will, what happen, what is the use of auto scaling? It will scaling up and scaling down as per the requirement, right? As per the customer requirement, the machines are will be okay, scaled up as well as scaled down. That's a good one. But what happened, what is the problem of this one? Okay, for example, if I using two applications, say course.html or welcome.html. Say I'm using two applications, but most of the customers are hitting the using the course.html only. 80% of the customers are using the course.html. Only 20% customers are using the welcome.html. But because of this, what happened? So unnecessarily, so this application also will be copied into the remaining machines, because the usage is only with the course.html, because most of the customers are hitting this URL. So this application accessing this application, but very few customers are accessing this application. But what we are doing, so because of the excessive RAM utilization, we are increasing the instances having both the applications, right? Okay, that means whatever the new instance you are creating, that instance will have the both services, both applications. But out of the two applications, one is not required for me. Only one thing, only one application, course.html is required. Welcome.html is not required. But what happened? Both are copied into the new machines. If you create 100 machines, so in the 100 machines also, so all the two applications will be available. But I don't want to do that. So I want to keep only one application in the, I want to increase, I want to enhance only the course.html only. Okay, I want to use only course.html only. I don't want welcome.html. So for that, what we can do? Okay, we cannot delete the welcome application, right? It should it should also be there. Okay, but that means not in all the machines. In the main machine, so these two will be there. And whenever you are doing the scaling up and scaling down, so only in the application level, okay, only in the application level only, okay, this should work. Only in the application level only, so this scaling should happen. But I don't want to do the scaling in the instance level, that is in the machine level. In the entire machine level, I don't want the scaling, auto scaling. I don't want in the entire machine level, but I want the auto scaling in the application level. Entire machine level is not required. In the application level is required. So for this, we are using the containers. Okay, for this we are using containerization tools. Understood? Why we are using the containerization tools, Docker and Kubernetes? Because the only the main advantage is we are scaling up the application, scaling up the applications only in terms of the level of applications only, not in the entire instance level or in the machine level. Okay, so that is a major advantage of the containerization tools. So I'll tell you one more scenario. So in the earlier days, okay, we are using virtual machines, VMwares. Hope all of you know about this one. Okay, so VMwares, so this will also do the same functionality. Okay, what is the VMwares have? On the VMwares, we have one main Windows machine is there. On the Windows machine, we are installing the virtual machine, the VMware software we're installing. On this Windows machine, we are installing the other OS like Linux or Ubuntu. So we can work. Okay, we are installing those OS. So what these are acting as a virtual machines. Okay, Linux machine, Ubuntu machine is acting as a virtual machines. So what is the drawback of these VMwares? So these VMwares will take the resources from this main machine only. Okay, these virtual machines will consume the resources from the main machine only. So because of that, what happened? So there is a slow. Okay, these machines are slow in nature. Okay, so for example, if you deploy the application, for example, I'm taking the same applications, you are deploying the two applications. Okay, you are deploying the two applications. So that let us take the Windows machine has the RAM capacity as 10 GB of RAM. Okay, so 10 GB of RAM is there. So let us take course.html. It is using the 6 GB of RAM. Okay, that means 6 GB of RAM is allocated for the course.html. Let us assume, so in the Linux machine, course.html is deployed. In the Ubuntu machine, welcome.html is deployed. So in the Linux machine, that means, so this course.html, it is allocated for 6 GB of RAM. So Ubuntu machine is allocated for 4 GB of RAM. So, but out of 6 GB of RAM, okay, so out of 6 GB, 6 GB of RAM, so course.html, it is using only 4 GB of RAM. It is using only 4 GB of RAM. Whereas welcome.html, it is using only 2 GB of RAM. Okay, so this is allocated one. Okay, allocated. So this is used one. And next, what is the wastage? So wastage RAM is, here it is 2 GB, and here also it is 2 GB. That means total 4 GB of RAM is wasted. Okay, by using the VMwares, so 4 GB of RAM is got wasted unnecessarily. If the 4 GB RAM is there, then we can run the one more application, right? But it is not possible with the help of VMwares, because the machines are allocated fixed to the system resources. Whatever the resources are there, so those will assign automatically. Okay, so that's why. So this is this is a major drawback of VMwares. That's why we are going for containerization tools like Docker. So what happened because of these tools? So these tools will consume the memory only in the application level. So they will deploy. We will deploy the applications in the containers. Okay, we will deploy the applications in the containers. So containers will have, okay. So there is no fixed allocation like this. So as per that depends on the utilization. So this will be allocated. Okay, therefore that we can run n number of applications. So depending on the memory. Okay, there is no fixed allocation like this. Okay, there is no fixed allocation like this. So as per depends on the requirement, so the usage will be there. Therefore, for example, if you take the same scenario, so here it is taking the 4 GB of RAM for course application and 2 GB RAM for, okay, for welcome application, and remaining 4 GB RAM, okay, can be used for another application. So we can run. So depends on the application usage, we can run n number of applications here. That is the main advantage of containerization tools. And moreover, so containers are lightweight. Containers are lightweight. So unnecessary lightweight means not in the uh, physical weight. Okay. So those are lightweight. That means those are having they will occupy very less amount of resources, system resources. They will consume only very less amount of system resources. Okay, that's why they are very light in weight. Okay, so next, so the main advantage is, so they are OS independent. That means if you if you prepare one image, okay, if you prepare one image, okay, with all the applications, the same image can be used for any type of OS. Okay, that image is suitable for any type of OS. For example, if you go for virtual machines, if the image you are built with respect to Linux, so the image will work only in the Linux. That is not suitable for Ubuntu machine. That is not suitable for Windows machine. Similarly, if you prepare an image with all the applications, so in Ubuntu, okay, so then that is limited to only Ubuntu box. That is not suitable for Linux. That is not suitable for Windows. But when you create the image by using the containerization tools like Docker, that image you can deploy in any OS, any operating system like Linux, Ubuntu, or Windows. So that is also main advantage of Docker and containerization tools. Okay. So likewise, we can say n number of examples. So these are containers are light in weight, so easily accessible. Applications are easily accessible and very fast. So what is the drawback of VMware? That is slow in nature, right? But so this is very, very fast. So containers are accessing the applications in the containers is very fast. Okay, accessing is very fast. Accessing the applications in the containers is very fast when compared to the VMwares. Okay, so that is the main advantages of containerization tools. That's why nowadays we are preferring the container based tools like Docker and Kubernetes. So what are the main advantages? One is memory saving. In short, you can call so memory saving, and next, so occupy less system memories. Occupy less system memories. They are OS independent. Okay, the images you are creating are OS independent. And next, accessing is very fast. Very fast accessing. So like this, we can, and moreover, we can also call high availability will be there. High availability. High availability means the application is accessible to n number of customers. So that, for example, if you deploy the application with some number of restarts, in auto scaling also we have the feature, right? So auto scaling also, it is main advantage is high availability. So high availability means, for example, if container, if an instance is deleted, okay, for example, if an instance is deleted, so what happened? Automatically, one more instance will come into the picture. Or if one instance is down because of huge utilization, RAM utilization, or CPU utilization, automatically one more instance will come into the picture. So that means the application is highly available to the customers. So without any downtime. Okay, so without any down, so the application is continuously available to the customers. That is the meaning of highly available. High available. Right? Any doubts in the Docker topic? Why we are using the Docker? Why we are using the containerization tools? Any doubts? So here I'll show the main difference between the VMwares and this Docker. So on the left hand side, you are seeing the virtual machines. So on the virtual machines, what it is having. So at starting, we have the infrastructure will be there. On the top of infrastructure, we have the OS will be there. That is system OS, main OS. For example, if it is a Windows machine, so Windows OS will be there. And on the top of that, we have the hypervisor will be there. So hypervisor is nothing but it is a software. Okay. So hypervisor, it is nothing but that is a software that will distribute the resources. Okay, that will distribute the resources to the existing machines, that is virtual machines. Okay, so here on the top of hypervisor, we have the guest OS is there. So each and every OS is a separate OS. It is a separate OS. So Linux. So this is let us take Ubuntu box. This is also CentOS box. So three different OS will be there. So if you remember, if you just understand this, so these OS occupy very high amount of memory. Okay, so if you know the size of each and every operating system, okay, Linux or Ubuntu or this one. So size of operating systems. Okay, operating system. Let us take Linux. So the base install Linux requires a 4 GB of memory. Okay, 4 GB of memory required. So for Ubuntu, so it is requires 2.3 GB of space. Okay, so 6.3 will be going to this one. So next CentOS. So it is required 512 MB of memory because it's a lightweight one. But if you take the two Linux machines, so it will take almost 8 GB of memory and one more this Ubuntu machine. So that will take 2.5 GB. So this is RAM utilization. If you take the ROM utilization, operating system ROM, okay, so storage capacity. So see here. So how much it will store? Let us take Linux operating system ROM size. So they will occupy almost 1 GB. Only base OS it is occupying 1 GB. Okay, 1 GB to 2 GB like that. So these operating system will take. So if your RAM, if your system, so in the olden days when you're using the virtual machines, so you know that virtual machines in the time, so those operating systems are come with very less amount of RAM, say 2 GB, okay, at the time. So 2 GB RAM or 4 GB RAM, okay, operating system it's come with 500 GB. So so with that operating system, so it is uh, very difficult to run the virtual machines. If you run the virtual machines, so your entire system will be hanged. Okay, because these OS will take the resources from the main system only. Okay, main systems only it will take. So in the each and every operating system, you will have the binaries and libraries, and in that applications are running. So all the executable files which are come with here. That means it is a separate operating system. Okay, it is a full separate operating system. It is not a customized one. Okay, so all the operating systems which are in over the hypervisor are full operating systems. Okay, they will occupy huge amount of space and resources. That's why it is very slow. So that's why because of this drawback, so we are containers topic are introduced. So in the container topic, so the main difference is guest OS is removed. Okay, the guest OS is removed. So because of this, huge amount of memory is saved. Okay, and it is very fast. So here, so what happened without guest OS? So if you see the layout and architecture here, so in the starting Windows infrastructure will be there, and that Windows operating system will be one common operating system will be there. On that we have the container engine will be there. So this container engine will distribute the executable files, that is binaries or library files, okay, which are from the operating system whenever required, which are required. That is only it is the binaries or library files which are required for the application level, application only, they will be called from the operating system. Okay, the binaries or libraries which are required for the application level, so they only called from the operating system. So here, so each and every unnecessary applications also which are running in the guest OS. Okay, for example, if you take this Windows machine, so go to the task manager. Okay, you will see the processes. So see here, 70 processors which are running in the background. So out of 70, some are useful, some are not useful at that moment. Okay, so but 70 processes are running the default one. So similarly for Linux machine also in background, so though which are not required for the application, they are running continuously in the virtual machines. Though they are not required for the application level, still they are running. Okay, so but they are it is unnecessarily occupying the space, memory. So that is a drawback. So, but that's why the drawback can be overcome in the containers by taking the binary files or library files which are required with respect to the application level. They only taken from the operating system. Okay, the rest of them are not taken. That's why the more memory space, more memory can be saved here. Okay, and moreover, so the applications are running in the containers. Okay, so the application in this operating system in this and in different operating system which are not no connection between each and every. There is no connection. Okay, there is no connection between each and every operating system. So containers and the applications in the containers are running without uh, communicating to each other. Okay, that's why so each and every application running in a separate container. So you can so understand in this way. So the main difference between the virtual machines and the containers. Okay, any doubts here? Okay. So now we will start the Docker topic. So Docker is nothing but it is containerization tool. So what is the what we can do with the help of Docker? So with the help of Docker, we are building the images. With the help of Docker, we are building the images and we are deploying the applications. Deploying the applications. So these are the major works of by using Docker. Okay, we are building the images and deploying the applications. Okay, so in Windows machine, how to install Docker? How to install Docker? So from Windows machine, okay, you can install the tool called Docker Desktop. You can download the Docker Desktop. So after downloading this, so just install this software. Okay, so I have already downloaded that tool and install that one also. You will get this file, Docker Desktop Installer. So after this, so just execute this. So you will get the option like this. You get the icon like this. So Docker Desktop. So when you install the Docker completely, so you will also see one tray here. So it is a ship symbol. In the tray also you can find this ship symbol. So here, if you do the right click here, you can see the number of options here. So dashboard, settings, so check for updates, troubleshoot, so switch to Windows container, about desktop, documentation. So dashboard means, so this is a dashboard you are seeing. So this is a dashboard you are seeing. And next, settings, you are able to see settings. Okay. And next, so these are the settings. I'll explain the settings. So check for the updates. If any new updates are there, you can check here. So next one, so troubleshoot. So if you are facing any issues, okay, in Docker starting, so then just troubleshoot this. You can see the options here. So switch to Windows containers. So generally we have two types of containers, Linux containers and Windows containers. So mostly we are working in the real time with the Linux containers only. That's why. So by default, whenever you install that WSL2, okay, tool, okay, so then you can get the Linux based containers. Okay. So if you want to work with the Windows container, just switch to Windows containers. Next, about Docker desktop, it is showing the version. Okay, so what is the current version you have installed? So it is showing the version. So it is an engine. So 20.10. The Docker version. So the Docker engine. So 20.10.0. So Docker version is 4.2.0. So here Docker Compose also will be there. So 1.29.2. So the advantage of Docker desktop is we can also work with the Kubernetes. Okay, we can also work with the Kubernetes locally, free in Windows machine, in the Windows level. Okay, but we can work with Linux machines. Okay, Linux operating system. So Kubernetes also we can work. The version is 1.2, 1.5. Okay, so likewise we can see the version also. And next, so documentation, you will get the complete documentation about the Docker. So quick start guide, that is also the guide. So Docker Hub. So Docker Hub means like a GitHub, we have the Docker Hub also will be there. Okay, so like a GitHub, we have the Docker Hub. So what is the use of GitHub? So the developers, they are writing the code, they are pushing the code in the GitHub repository. Likewise, we have a Docker Hub repository also there. So Docker Hub repository also there. You can create the Docker Hub repository. Simple sign up. So Docker Hub. So in this way, currently I have 3 images. I'll tell you how to push the images into this repository. So you can create this one. You can create the reports. So Docker Hub repositories. Next one. So this is my account, Docker Hub account. So this is a Kubernetes. Okay, that is working with docker.desktop. So pass, restart Docker. So quit Docker desktop. So these are the main tools in the Docker. So if you click on the Docker desktop, already it is open. So here, this is the main layout. This is the main layout. Here you can see the containers. Okay, that means all the applications which are running here. Okay, so images, if any images are there, so these are the images. Okay, so out of this, so these images are come with installation only. So this is a K8s. K8s means Kubernetes. Okay, K8s. The short form of Kubernetes is K8s. Okay, so when you enable the Kubernetes, so these will also come into the picture. So these images are come with Docker. So default one. Okay, these will come with a default one. Okay, so they are not installed by myself. When you install from your end also, so these images will come into the picture. Okay, only I have installed these two images I have in my local. So rest of all the images are come with the installation only, default installation only. So next, volumes. Okay, so next Day31 environments, so they're not required. So come to the settings. So here you can see the option settings. So in settings, you have the general options. So no need to disturb these one. So just keep this as it is. So start Docker desktop when you log in. So when the system is on, so Docker desktop will run automatically. In the real time, this option is must. Okay. Next, so resources. So see, this is very important. I already told you. So as my machine is having 4 GB of RAM, so Docker desktop, it is maximum allocated for 2 CPUs. So it is this is i3 processor. So having, so it is allocated for two CPUs and memory. So you can change the memory, required memory you can change here. Okay, you can change the required memory, whatever, how much you want, but it is comfortable and we can work with other applications also when you keep the memory as less as possible. So I'm keeping the 1.25 GB. Okay, if sometimes if it is throwing the error, okay, when you start the Docker desktop, sometimes it is throwing the error like so not enough memory. Okay, Docker cannot have enough memory to launch. So in such case, just go to the settings, just click on the resources to check the memory. So just reduce the memory. Okay, just reduce the memory, then your Docker desktop will start automatically. So apply and restart, so Docker will run. So if you get any error with related to the memory, just reduce the memory. So this Docker will will take less memory because my memory is only 4 GB of RAM. So other processors also which are running. So you can check the usage of RAM here. Okay, you can check the utilization of RAM. So here it is memory. So see here. So it is having 4 GB of RAM. Out of 4 GB RAM, so see here, 3.3 GB RAM is already allocated. But my system is running efficiently. If you use the same Docker in your machines, in your laptops or desktops, so your laptop will hang, desktop will hang. Why? What is the reason? The reason here, I'm using the SSD. My hard disk is SSD hard disk. So that's why, even though RAM is 4 GB RAM, so it is able to sustain. Okay, see here, the RAM utilization is very, very high. 87% of RAM is using. So your laptops having 4 GB RAM, so cannot handle this Docker desktop. So the two ways is, one is you can increase the RAM, or second one you can add the this SSD. Okay, you can add the SSD into your system. C drive you can make it as SSD. So see here, here also you can see. So disk 0 C drive, it is SSD. That's why it is very fast. So whereas disk one, so it is having two drives, it is HDD, hard disk drives. Whereas it is solid state disk drives. So that's why it is very fast. When compared to HDD, SSD are very fast in nature. That's why even the memory taking is very huge. So my system is running efficiently without any hang. Okay, so that's why. So my suggestion is to enhance the RAM size, or to use the SSD. Okay, or the third option is you can go for AWS, that is cloud. Okay, so that is the main so memory here. So next is swap memory. So next, disk image size. So default Docker, it is given for allocated for 64 GB of RAM. So 64 GB of ROM. So out of 64 GB of RAM, currently I'm using 3.9 GB. Okay, so out of my total complete memory is about 500 GB. Out of 500 GB, 64 GB is allocated for Docker desktop. So that is the main advantage. So containerization tools are taking very, very less amount of memory, both RAM as well as ROM. That is the main advantage. Okay, so next, so these are not required. So Docker engine. So currently it is using 20.10.10 the version. So next experimental feature. So Kubernetes. So very, very important. So in the Kubernetes topic, I'll explain this topic. So in the Docker desktop only, we are just simply enabling this Kubernetes option. We can also work with the Kubernetes. Okay, so I'll tell this option later in the Kubernetes class. So next, software updates. So I'm just unchecking this one. Don't want to update automatically. Okay, cancel. So these are the features and settings in the Docker, and the troubleshooting. So if you have any issues in the Docker, it is not running, so just restart the Docker desktop. So support. So reset Kubernetes cluster. Okay, this option is enabled when you enable the Kubernetes on. So clean or purge data. So you can clean the data. So if it is consuming more amount of ROM, okay, then you can clean this one. So reset factory details and defaults. So you can reset the complete Docker desktop. Okay, so this is my Docker desktop account. So that's it. So these are the options which are there in the Docker. But we are not working with this Docker dashboard. Okay, we are not working with the Docker dashboard. So we are working with the command line mode. We are working in the command line mode. So once you install the Docker, my screen is visible, right? Size is okay, font size. Okay. Right. So the very first command we will start with Docker. So when any tool is installed, you need to check whether whether the tool is installed or not. So with that, the Docker version. The first command is Docker version. So see here, so Docker double hyphen version, it is giving the Docker version. So it is 20.10.10. Okay, so again, we have one more command with the same Docker version. So Docker version without double hyphens. So it will show the complete information of Docker. Okay, if you click on two hyphens, if you type the two hyphens, then it is showing the only Docker version only. If you type this one, it is showing the Docker client as well as this server. So Docker engine means it is the community. So where we have the server information, where the server information will be there. So when you install the Docker and you need to check, so you need to see both the client details as well as server details. So then only your Docker is completely and perfectly installed. So if you are not showing any server information, so you need to check with the installation process again. Okay, because we have some pre-requirements for Docker. I already told you the pre-requirements. What are the pre-requirements? So you need to meet all the requirements. So then only this Docker will be installed in your local. Otherwise, it is not possible to work with the Docker in your Windows machine. Okay, so here it's about the client as well as server. You can see these two things. Right? So next one more command, so Docker info. So this also give the information about the complete detailed information about the client as well as server. So this is the client here. So here debug mode is false. So here Docker scan, it will show the version of the Docker. So plugins, what are the plugins which are there in the client? That is client means our local site, our Windows machine. So server means we have the main server will be Docker server will be there. So in that containers are running total 67 containers. So running are 60, stopped is 7. So total images are 20. So currently in my local, so these information is there. That is in the server side. Server side total we have this information is there. So server version is 20.10.10. Okay, storage driver. So next we can see the complete details of this Docker here. Okay. So next, what is the OS type? So it's a Linux based. Okay, so as we are working with the Linux containers, right? Switch to Windows containers means currently you are in the Linux containers. That's why it is showing the OS type is Linux containers. So Linux OS. So operating system is Docker desktop. So kernel version. So it is architecture is 64-bit. CPUs are 2 CPUs. Memory is 1.2 GB. You are given. So like this, you can see the complete detailed information of Docker by using the Docker info. So here you have 3 commands. Okay, commands. So the first one is Docker double hyphen version. So Docker version, Docker info. So these 3 will give the information about the Docker. Understood? So now coming to the main tools. Now we are working how the Docker will work, how the Docker will take. So how the Docker will work means, so currently, as I told you, I have shown the image, right? So in the image, so what happened? So we are working with the Docker, that is containerization tool. So here the container engine, it is there. So we are taking the image from the repo. Okay, we are pulling the image. For example, if you want to Ubuntu image, okay, instead of installing the corresponding OS over hypervisor, so here we are pulling the image. Okay, we are taking the image of Ubuntu, we are taking the image of Linux machine or any other OS. Okay, by using a command called Docker pull. First, before that, we are searching the image name. Okay, we can search the image name. So here, remember, in our Docker desktop, mostly we are using with the Ubuntu machine only. Why Ubuntu machine? We can also work with the Linux machine. We can also work with the CentOS machine. But so Linux and CentOS are costly. They are not free. Okay, they are not free. Ubuntu is only free one. So for using this, charges will be there, and we have some separate process will be there. That's why we are using only Ubuntu machines. So, but however, whatever the image you want, so just with this command, so docker search Ubuntu. So that is operating system, the name of the operating system. We can get the operating system. Okay. So first, after searching the operating system, so we are pulling the operating system. So docker pull Ubuntu. Okay, so that means operating system Ubuntu is now installed in the container, level, not in the OS, complete OS level. So it is installed in the container level only. Okay, so now let us check these two commands. So docker search. Let us take the Linux. Let us check whether it is existing or not. So see here. So we have the Linux server is there. Okay, so here when you search any image, so it is showing these information. So first name of the image, second one description, and next one stars, number of stars. So number of stars means that is highly rated. So we can use that trusted image. So remaining images also will be there, but they are customized images. They are customized images. So see here, it is a MariaDB container. So brought to you. So by Linux, something information will be there. That means, so in this Linux machine, they are installed the MariaDB. So if anybody want the MariaDB database, so then you can go for this image. Okay, so if anybody want any other option, so depending on the operating system, main OS, so this is the main OS, and top is main OS. So all these are customized OS. All these are customized OS. So as per the requirement, you can use the customized OS. But it is always preferred to take the default one. But remember, the size of default one is somewhat high. Okay, when compared to the remaining one. So these are customized ones. So they are also having high size, but the customized applications will be available on these machines. Okay. So let us take the CentOS. Let us check CentOS. So see here, CentOS is available. So the official build of CentOS. So it is having 6,900 stars. So it is official. So these are automated. That means customized one. So see the number of stars also here. So as per the requirement, you can use these images. So similarly, if you check the Ubuntu, so this is a Ubuntu image. So in Ubuntu, it is a Debian-based Linux operating system. Stars. See the number of stars. It is official. So likewise, all these are customized operating systems. Remaining all are. So currently, we are going with the Ubuntu machine. So if we take the for that command is pull docker pull Ubuntu. So it is taking the tag as default tag. Tag means version. So which version you need to take. So by default, it is taking the latest version. So it is showing already exist. Okay, if you want to show the recent images, so docker images. The command is docker images. So what are the list of images which are available? So here, that image is already available here. So docker image, this one is already available. So just I'm removing this image. So I'll show the process. Okay, so image is deleted. We check the docker images again. So there is no Ubuntu. Okay, now I'm installing the docker again. So docker pull Ubuntu. So Ubuntu box already exist. Let me remove that one. Delete it. Okay, let us try to install. One. Okay, let me do one thing. So this is the command docker system prune to delete all the resources in the Docker. Now you see, now it will still exist. Ubuntu. Okay. Just a minute. Okay. Okay, let us pull the image. Yeah. Okay, I'll show this process of how to install the Ubuntu image. Okay, whenever you pull the Ubuntu, so taking it is taking the image from the repository. Okay, and it will come here. So when you type the Docker images, so then it will show here. So let us do one more thing. I will stop the Kubernetes because Kubernetes pods are restarting here. Docker RMI and Okay, this image is restarting. Okay, I'll tell you the process how to do the installation of Ubuntu. Okay, uh, because already Kubernetes is already running here, so it is showing. Okay, anyway, I'll told you this how to do this Docker images. That is how to install the Ubuntu. So just by using the command docker pull Ubuntu, so the image will be pulled. Okay, image will be taken into this local Docker desktop. So here after getting the image, so we need to log in into the image. Okay, so just we need to move into the image. So for that, so here after pulling this, so we can also do this two things: Docker search Ubuntu, Docker pull Ubuntu with the help of one more command called Docker run. So Docker run is the command that is used to log in into the container. Okay, that is we can log into the container by using this command. So Docker run -it. Okay, so here you need to give the port name. So for example, if you want to run the container in any particular port, if any port, okay, so we have some already told some range will be there, the port range here. So that is 30,000 to 30,265. So up to this port range will be there. So okay, we can use any port range here. So I'm giving the port range as say 31,000. So colon 80. So 80 is the container port. Okay, where it is application is running. That means the application which is running on the port 80, that is targeted to this 31,000 port. Okay, so that is the meaning of this assigning the port here. Okay, so 31,000 here. You need to give the port image name here, Ubuntu. So this is the command used to, so when you execute this command, so what happened? This command will automatically search the image, automatically pull the image. That means, so Docker run. So this is the command. It is the combination of two things. One is search, other one is Docker pull. So this run command will do the two functionalities. So now if you execute this one, so Docker run here, one more thing here I want to explain about this command. So here Docker run -it. IT means iterative terminal. So IT stands for iterative terminal. So here we have two commands. So one is IT, another one is ITD. ITD. So what is ITD means here? Iterative terminal detach mode. Okay, iterative terminal detach mode. So what is the meaning of what the difference between these two is? So when you execute this command, you are moving into the container. You are inside the container. Inside the container. And whenever you are executing this command, so command will be executed, but you are not in the container. Okay, command is executed, but not in the container. But you are not in the container. You are not moving into the container. That's the difference between these two. So first, let me log in into the container because I need to do something there. Okay, so that's why I'm giving the -it. -p means port. You are giving the port. So giving, you can give any number of port. It's not a problem. So just click on the enter. Whenever you click on the enter, so see here, you are now in the Ubuntu box. Now currently you are in the Ubuntu box. So now you can do whatever you want. You are logged in the Ubuntu box as a root user. Now, for example, if you want to deploy an application, okay, so whatever application you have done, okay, you can create the application here. So I want to install the Apache 2. So the command is apt install Apache 2. So see, the package is not there because it is a fresh operating system. So you need to install the operating system. Sorry, you need to install the package, but the package is not available in the app repository. First, you need to do the upgrade. You need to the update. So update the repo. Apt update. So whenever you do the update, then only Apache 2 package will be available. So packages are up to date. Now you can install the command, the Apache 2. Apt install Apache 2. Asking for Y, give Y. So Apache 2 package is installed. Since it is Ubuntu machine, so Apache 2 package is available. Now you can create an application and you can deploy the application. So currently you are logging into the container, okay, Ubuntu container, there you are working. So if you see the operating system of Ubuntu, it is having only 80 MB. Okay, the size of Ubuntu is 80 MB. Whereas if you install the in the virtual machines VMwares, so that this same Ubuntu box it takes 500 MB. So it is taking very huge amount of memory in the virtual machines. Whereas in case of containers, it is taking very small amount of memory, say 80 GB, 80 MB. Okay, package is going to be installed. So see here it is asking for some details. Okay, so which country currently you are, which region you are currently in. So currently we are belong to, okay, Asia. So that's why U6. So in that area, so what is the time zone? So the time zone is Kolkata, right? Our time zone is Kolkata. So give 44. Click on enter. So based on the time zone, it will take. Right. The package is installed. So if you take the Apache 2 version, Apache 2 version, so it is showing the version as 2.4. Now here you can create the one file, HTML file, and you can deploy it. So how to create the file? So the package is VI. So VI, okay, here in VI is not working. You need to use VIM. VIM editor, you need to use same editor, there is no difference. Okay, VIM, let us take welcome.html. So VIM is not found, you need to install the VIM also. Apt install VIM. Okay, so VM is installed. Now you can create welcome.html. Now here you can give text h1. Welcome to Docker classes. H1. Just save this. Okay, now I want to move this package into the path /var www html. So deployment is done. Now, so now if it is a normal virtual machine, just we are accessing the application by using the IP port followed by the context path. But this is a container level, so it is not possible to access application with the IP. Okay, but here we can access the application by using the port, the local host. So however, we can access that later, but we need to, now what happened, we are just taken the base Ubuntu image, and on the image we are worked that, so we are installed the Apache 2, and then we are deployed one application called welcome.html. Now enter this package, okay, we need to create an image. Okay, how we are creating the Amazon machine image, likewise you are creating the entire thing as an image. So to get the image, first you need to come out of this this container, Ubuntu container, you need to come out of this. So to come out of the container, you need to use control P Q. Okay, you need to use control P Q. So if you do this, you can come out from the container. Come out from the container. So we can also come out from the container in one more way called exit. Simply if you type exit, so you can come out from the container. But what happened because of this? So the changes, whatever you do, those will be lost. So whatever the changes you made, so that will be lost, and the container will be stopped. Container will be stopped. So these two things will happen. That's why don't do exit. So just to do control P Q. So see here, I just come out of the container now. Now Ubuntu image available with this package. Ubuntu image is available with the package. Now I want to create one more image. Okay, I want to create one more image with this details. That is welcome.html is available in the this Ubuntu box. Therefore, I need to create one more image. So with the name. So for that, the command is docker attach. Okay, so docker attach. Just a moment. Here. Okay, the command for creating this is docker commit. You need to create the image with the name of docker commit. So docker commit, so followed by the this container ID. That is whatever the container ID. So just if you take the docker images again. So here the image is Ubuntu name. So here this is the image ID. So and the command for in the containers is docker ps. So docker ps is this is a docker container. Currently you are create the container. So see the container is running in the 31,000 port. Okay, so what is the command? Docker ps. Okay, so docker ps is the command to see the running containers. To see the running containers. And one more command, so docker ps -a. So this is a command used to see both running and stopped containers. Okay, so both two containers you can see here by using the docker ps-a. Okay, so now I want to create an image, so with the help of this container. Okay, because this image will have the Apache 2. Okay, So, but one more thing I want to do, because I just deployed the application, but I did not start the application. I did not started the Apache 2. So therefore, I need to move into the container again. So to move into the container, the command is docker attach. Docker attach. So you can take the container ID, you can give it first 4 letters, or you can give the full name, your wish. So at least 4 characters are compulsory. So see here, so docker attach is the command used to move into the container. Docker attach. So give the CID. CID means container ID. At least 4 letters you need to give. Okay, so to move into the container. Now, if you see the package, whether it is available or not, cd where www html do ll. See the package welcome.html is available here. So I want to start the service. The command is service Apache 2 start. We're going to status first. So Apache 2 is not running. You can do start. So Apache 2 is starting now. Now you can see the status. Apache 2 is running. Now you can come out of the container. So control PQ. So read escape sequence. So you are now in the Windows machine again. Now here you can create the image with the help of this container. So for that the command is docker commit. So before that, see the container. See this is a container ID. Image is Ubuntu. So here the command is bash. So created 12 minutes ago. Status up 12 minutes. So ports. So here 31,000 port it is listening, and 80 is a target port. The name here, any name that is given, is a random name that is given. So no need to worry about the names. So for with this image, I want to create a new image. Okay. So Ubuntu is a base image. On that base image, I have created, I have installed the Apache 2, I deployed one image. Now with that image, okay, with that content, I want to create a new image. So for that, the command is docker commit, give the container ID, at least starting 4 letters. Okay. So now give any name for the image. So I want to give the image name as welcome. Welcome followed by the version. So I'm just giving the 1.0. This is the version. If you're not given 1.0, it is taking the default as latest. That's why I'm specifying the version as welcome colon 1.0. So click on enter. So now it is created. Image is created with this ID. Now, if you see the Docker images command, we use it to show the list of images. Now, I have created the welcome image with the tag 1.0. This is the image ID. So created 12 seconds ago. Size is 273 MB. So see here, Ubuntu size is 72 MB. So whereas welcome image size is 273 MB. That means why the size is increased? Because you have done some changes, right? You have updated the repo and you have installed the Apache 2 and you have started the container and you have deployed the application. So all these things will affect. So therefore, the size of the image will be increased to 273 MB. However, you can use this image anywhere in any operating system. Okay, if you want to use this image, you can use this image in any operating system. That is the main advantage of the containers. You can install this. Okay, you can just use this image in CentOS, you can Ubuntu or Linux, in any operating system, this image will work. Okay, now I want to access the application. Okay, I want to access the application. So, but application is available in welcome image, right? The application is not available in the Ubuntu. The application is available in the welcome image. Therefore, I want to access the application by using the command. So docker run only. So docker run. So here -itd, because I'm not logging into the container again, because at the starting I have taken the base image Ubuntu, I have made the changes and I have created an image. Now again I want to access this image, okay, in a particular port. in a specified port. So say that's why I'm not logging into the container again. The command is docker run -itd detached mode -p and specifying the port. So with any port you can give 8080, you can give any port. So colon 80. Now here I'm giving the image name. So what is the image name now? It is welcome. So therefore welcome, you need to provide the tag also 1.0. Now what happened because of this? If you click on enter, so now you are not moving into the this image, and moreover you can access the application by using the 8080 port. Okay, now just click on enter. Now this is the container. New container will be created. So if you see the container list, so docker ps this is a command to list out the containers. So this is here. The new container is created with the image welcome colon 1.0. So it is status is 8 seconds before. So it is available under 8080. It is given some other name. Now you can access the application by using the local host. Local host colon. So what is the IP here you are given? In the port you are given 8080. Therefore 8080 followed by. So the context path is welcome.html. Welcome.html. Okay, why it is not started means here in this image, so this Apache 2 is not started. That is the reason, because we can enable the this we can make the auto start of the service, right? So by using systemctl enable service name HTTP, that will it will start the service with the boot time. Okay, that part we did not done. So therefore the service is not running. That's why it is not access the application. So now just move into the container again. So docker attach. Just move into the containers. Doc attach. Now check this service Apache 2 status. See, Apache 2 is not running. So just start it. Apache 2 is running. Now just come out of this one. Now you are able to access the application. Now if you just come out of this one, control PQ. So even though you are able to access the application, but you need to make the service as auto start, because every time you don't need to log in into this one, okay, and check the service is starting or not. You need to make it as auto start. So auto start means for this, in case of virtual machines, you can make it as system ctl, okay, enable Apache 2. So this is the command will work, but here it is not work. System ctl command is not working in this image. Okay, so service Apache 2 enable. Let us try this command. So this is also not working because it is showing the options only these things. So for this, you need to do some more creation. That means you need to create some script. Okay, you need to use script file. So we just move into the /etc in the folder init.t. Here you need to create one script file, script.sh. Here you need to make the command as service enable, sorry, service Apache 2 enable. Let us try this. So for that source this is not. So we have some other method. So to make the Apache 2 as auto start. So permission denied. So with the full permissions, do ll. So script don't have this executable permissions. Therefore, use chmod 777 script. Now can you execute this? No, it is not sh. Again, it is showing this thing. Now let us do one thing. System ctl enable Apache 2. No, this is not showing. Okay, we will do this later. How to do the auto start, because now it is a normal machine, then virtual machine, then we can by using the command we can make it as auto start, boot up start. So, but this is a container level. So now anyway we are accessing the application, right? So this is the process for accessing the applications in the container level. So here the application is running in the container level. Okay, the container level. So these are the major commands we are working with the Docker. So Docker attach, Docker PS. Okay, so mostly these are the commands which are working. And one more thing here, currently this is the Docker images. Now here I have the image welcome to the tag 1.0. Again, if we move it to the, now I want to create one more same account, that is same image with a different tag. Okay, so I have updated this image, okay, with new version 2.0. Therefore, what I can do, I have, so let us take one more application I have deployed here. Just move into the /var www and html. Okay, here I'm creating vim, say Docker, say docker.html. Here I'm giving, okay, h1. So this is Docker classes. This is Docker class. Give any name, h1. So I have directly created the file in the particular folder /var, in the deployment folder only I have created this docker.html. Now let us check the service is starting or not. Service Apache 2 status. So it's running. So I'm coming out of this one. Now I'm creating one more image. So for creating the one more image, before that, so see the containers. So Docker, to see the containers, the command is docker ps. So in the interviews, they're asking these commands. So by which command you can see the running containers. What is the command used to see the stopped containers? So these are the commands they're asking. So here the command, here it is, docker ps is a running container. Now I want to create new image with this existing container, because in this container, in this image only, I have created some more deployment. Okay, so for that command is docker commit. Docker commit. So give the container ID followed by the image name. So let us take welcome 2.0. The version is 2.0. Now the new image will be created. Now I want to access this application in some other port. Okay, because welcome colon 1.0, there is application, there is an image. Okay, in that image we have the welcome.html application is there. That application is accessible on the port 8080. Now I want to access the docker.html file in some other port. So for that the command is docker run -itd, because I'm not logging into the image again, that container again. Therefore itd-p, that is a port you can give. So here let us take the image as 8100 and the target port is 80. Okay, so here giving the image name. So what is the image name here? Welcome dot, okay, 2.0, right? So before that, just check the images. So see here, welcome 2.0 tag 2.0 will be created about a minute ago. Now I'm assigning this image to a port. So docker run -itd -p. So give the port as 8100. Okay, so target port given. So give the welcome colon 2.0 now. Now again a new container will be created with the new port 8100. That means the image is running in the port 8100. So for that, to see the containers, docker ps. Now see here, the new container is created. Under this container, we have the uh, docker.html is there, and this is running under the port 8100. Okay, so if you try to access the application with 8100 port, 8100 followed by docker.html. It is not accessible because that is not running. So therefore, login into the port again. There is a container again. So for that, so docker attach. So docker attach is the command to log into the container. Docker attach. Now in the container, now just move into the cd var www html. So you can see the packages. Docker html is there. Now you need to start the service Apache 2 status. So it is not running. So start the service. Now it is running. Apache 2 is running. Just come out of this. Just access this. Now this is Docker class. Likewise, we can work with the Docker. Okay. So now one more thing. So Docker images. So any doubt here up to this part? How we are creating the images with the Docker? How we are accessing the application? Here one more thing we need to do, because every time the service we are starting manually, but that is not to do. We need to make the service as auto start. So that process I'll show tomorrow. So till now, if you have any doubts, how we are creating the image, how we are running the containers, how we are accessing the applications, any doubts? Hello? Hello, am I audible? Are you there?
Yes, sir. Yes, sir. It's ready.
Okay, okay. Any doubts here up to this part? So what we did from the starting onwards. So first we pull the image. Okay, first we pull the base image Ubuntu. Okay, so and we are taking that Ubuntu in some particular port, and we are logging into the image. Okay, we are logging into the image by using this command. So -it. So we can log into the container. Okay, so Ubuntu is nothing but when you are taking the image, so it is taking the container. It is nothing but a container, Ubuntu container. So if you see here, Docker PS, so it is taking the container only, the base container. 29 minutes ago, you have taken the container. It is running the 31,000 port. Okay, so if you want to log into the container, you can use docker run. So this command you can use, or docker attach also you can use. Okay, docker attach also you can use. You can use any one of the command. So the difference is here if you use -it, so you are logging into the container. When you -itd, you are not logging into the container. Okay, but you can execute the image. You can operate the image with the port you specify. Okay, so docker run nothing but will do the two functionalities like search and pull. And after that, when you log into the container, and you can do the activities, you install the package, okay, and you can deploy the application, and you can come out of the container by using the control PQ. If you do exit, the changes will be lost. And Docker PS is the to see the list of container running containers. So PS-8 is used to see both running as well as stopper containers and Docker images. It is the command used to see the images. So this is a part we have done up to now. So if you see the Docker PS-A. So currently there are no stopped containers. If you stop any container, then it will show it. Now one more point. Now I want to push these images to my repo. Okay, I want to push these images to my repo. So Docker Hub. So I have some Docker Hub account. You can also create. It's a free account only. So after creating, I want to push that images into this repo. So for that, what is the process? So for that, first step is you cannot directly push the images like by using Docker push followed by the image name. So like welcome.1.0 like that, you cannot push. So if you try to push, so see what happened. So Docker push 1.0, it is throwing error. It is throwing error because, so see here, it is throwing error because request access resource is denied. So here you need to do one more thing. So to push the image into the repo, first you need to give the tag. Okay. So to push the image into repo, you need to add the tag. You need to add the tag to the repo. So what the command to add the tag is Docker tag. Docker tag here, how you are giving that tag means, so the tag should be given with the Docker Hub username. You need to give the Docker Hub username followed by the image with version. So here also you need to give the image version. So this is the command. So Docker tag, here you need to give the Docker version space. So you need to give the username of the Docker Hub and you need to give the image and version. So this is the tagging. That means whenever you give the Docker Hub username, it will identify the repo user. It will identify the repo user. But before that, you need to make the communication with the Docker Hub from your local to the remote hub. So for that, the command is Docker login. So Docker login is the command used to give the credentials to communicate with the remote repository. So it is asking for the username and password. After giving the username and password, so it is showing the login succeeded message. If you want to sign out, so just log out. This is a command used to Docker logout. First, I will show the Docker logout. So it is removing the login credentials. Now there is no login. Now I want to log in into the Docker, my Docker. So Docker login. Now it is asking for the username and password. So username is, so it is my username and my password I'm giving. Here it is login succeed. Now you can add the tag to the existing image. So for that, first what are the images are available? So welcome 1.0, welcome 2.0, two images are there. So for that I adding the tag. So Docker tag. So first I need to give the image name. Let us take 1.0 and followed by the username, my username followed by the image name. Whenever you do this, so the new image will be created with a tag name. Now, if you see the Docker images again, you will find a new image. So this is a new image with a tag name. Now you can push the image. Docker push. You can specify this. Remember, followed by this colon is very important. This version is very important. Otherwise, it won't recognize. So if you see this, I'm removing this one. Click on enter. So see here, it is taking the default tag, but it is not available. Anyway, it is throwing the error saying the image is not available. See, tag does not exist. So if you're not giving any tag, by default it is taking latest tag. But with that latest tag, there is no image available here. That's why you need to mention the tag. Now that image will be pushed. It will take some time. See, total 272 MB is there, right? So it is taking some time to push the image. Total 273 size. So after once the image is pushed, so here if you do the refresh, here the image will be available. So in this way, we are working with the Docker. So any doubts up to this part? So most of the topics are covered in the Docker. So same process you can do in the Linux machine also. Same thing. So tomorrow I'll show how we can work in the Linux machine. And also remember, in the real time, this process is not followed. In the real time, this process is not followed. In the real time, mostly they are working with the Docker files. Docker file. That means whatever the activity we are done right now, all these will be placed in the Docker file in the form of commands. So hope you are remember Jenkins file, right? In the Jenkins file. So in the pipeline, how we are doing the script, how we are writing the commands, the same thing we are putting the Jenkins file with the name as Jenkins file, and we are pushing that Jenkins file in the in our repository. And when you are creating a pipeline job in the Jenkins, you are giving the option. So pipeline from SCM. Okay. So there you are giving the name as Jenkins file. Just remember the topic, recall the topic. Okay, just you can understand. So same way, in the same way. So whatever the activities you performed right now, till now, the same thing you are placed in the form of commands in the Docker file. So with a single command, so Docker build, we have a command called Docker build -t. Okay, so followed by the image name. Okay, followed by the image name. So dot. Okay, next one, we are giving the file name -f. So Docker file. Like this, with a single command, we are building the image. Okay, with a single command. So this is the command, this is the image to be created. Okay, for example, I want to create with a new name, welcome colon 3.0. Okay, so this is a new image name. So you can give any name here. So -f file name, so Docker file. So this Docker file should contain all the commands. So with this single command, we are creating the image. So the topic we will show tomorrow. I'll tell you tomorrow along with the Linux machines, how we are working with the Linux machines. Okay, so it is taking some time. So I'm skipping here because it is taking some time. Memory wasted, right? So here images, you can see. So Docker images is used to show the images, and Docker TS is a it is showing the running containers. Docker TS hyphen it is showing both starting, running as well as stopping containers. Okay, so remember these commands which are very important in the interview point of view, right? If you have any doubts, you can ask me. So otherwise, you can leave the session.